Hi, this is Mrs. Vrobel. This is Chapter 12, Part 2, States of Matter. So in the previous slides, we were talking about kinetic molecular theory. We're also looking at Graham's law of fusion. And today we're going to talk about gas pressure. So as I blow up this balloon, depending on how much air I put in this balloon, the gas particles are essentially exerting pressure on the inside walls of this balloon, and they're constantly colliding with the walls. And when they do that, they exert a force, which we call pressure. So notice that pressure is the force over the unit area. So please remember, in our atmosphere we have pressure everywhere, and this is something that students routinely have problems with. Is there's less air pressure at high altitudes. If you ever look on a box of cake mix, they usually have a separate set of instructions for high altitudes. There's less air pressure, and because of that, water actually boils at a different temperature. And this is something that you might want to keep in mind if you're ever in a high altitude area. Now, there's something what we call a barometer. You probably heard of it when people talk about the weather, the fact that the barometer is falling or rising depending on what the weather pattern is. But notice with a barometer, it's a cylinder that actually it measures the height of mercury. There's barometers now that don't use mercury. They use a metal piece that actually fluctuates depending on what the pressure is. But in the original times, there was a man by the name of Torricelli. He created this barometer based on how much pressure was pushing on the mercury. And obviously, if you have more mercury that's being forced up through the tube, the higher the units, or the higher the height of the mercury. So more pressure, higher the height. In the lab, we actually have what we call a manometer. So if you were doing a reaction where you were trying to measure the pressure of a gas in a container, the height of the liquid in the manometer would actually tell you how much pressure is within the gas. So notice that the more gas, or the higher the pressure, the higher the height is of the manometer. So when we talk about pressure, we're going to be using the units of Pascal. So Pascal is the metric equivalent of pressure, and notice that it's newtons over meters squared. Another unit of pressure that we tend to use with chemistry is called atmosphere. And notice that 1 atmosphere is equal to 760 millimeters of mercury. Going back to that barometer, the height of mercury for 1 atmosphere. Another unit that you will see with gas pressure is 101.3 kilopascals. So get yourself familiar with these type of units, because you'll see them over and over again with gases. Okay, here's just a table that shows you the different units. You could have what we call torr. Torr is an older unit, not used as frequently with the more modern equivalent of ATM or pascals. And also PSI, that's obviously an English equivalent that you may have heard, like if you're filling your tires, they're measured in PSI as opposed to millimeters mercury or atmosphere. Okay, now what can we use to explain pressure? You can actually look at what we call partial pressure, and what that means is if you have a mixture of gases, the interesting thing is that the mixture of gases is equal to the sum of the pressures. So we're going to do some problems like this in class, where we look at the individual amounts of each gas, and each gas exerts a certain amount of pressure, and we can actually add up those pressures, and we will do problems like that. Because of that, the amount or the number of moles actually helps determine the partial pressure. So we'll be doing problems like that. And notice that it's independent of the type of gas. So it doesn't matter whether it's nitrogen or oxygen or hydrogen. It just matters about how much of that gas is present to give us a certain pressure. Okay, so for instance here we have 1 mole of helium and 1 mole of nitrogen. And all that matters is the amount of each. So we have 2 moles of them together, and each exerts a certain pressure based on the amount of the gas. Okay, this is the general formula. So for the total, so PT is the total pressure, we're looking at the individual pressures and we're just summing them up. So if we have 5 gases, we'll have 5 pressures added together. Now, with Dalton's law, we have to use what we call mole fraction. So with mole fraction, notice it's x sub 1, and we're going to use n to represent the amount of moles. So the individual mole is going to be divided by the total moles, and that's going to give us x sub 1. So if I have 1 mole of hydrogen and there's 2 total moles of the gases, it'll be 1 divided by 2 for x sub 1. And then that is actually going to be multiplied by the total pressure to give us the partial pressure of a gas. Okay, so solving these kind of problems, the first thing is you want to figure out what is the moles of the gas. That's the very important step for number 1. And then you're going to essentially add the individual moles to get the total moles. So you want to add them up so you can get the denominator. And then you're going to find the mole fraction of each gas. So notice, like I said, it's the individual moles divided by the total to give you the mole fraction. And then you take that x sub 1 and just multiply it by the total to give you the individual pressure. Now there's a couple different ways that you can do things. You're going to add up the total or the individual pressures to give you the total pressure, or you could subtract to find a missing pressure. And we will practice those kind of problems in class.